Hi, Algebra 1. In lessons 6 and 7 here, we're going to be working a lot with factoring. So writing an equation from standard form into factored form. Here we go. In figure A, I know that this short side is 2, and I know that this short side here is 2 because this whole thing is 5 and this is 3, which makes, if I add that on to 8, which makes this side 10, and so the area is 20. In this figure, there's a lot going on here. If I know that this side is 12, then this side has to be 5 to have an area of 60 right there. And then that means that this portion here is 5. Now, altogether, this is 8. 8 times 6 is 48. So that means that this part right here is 5. And if this whole piece right here needs to be 12, then this part right here needs to be 4, because that will add up to 12. Now, 4 times what gets us 36, and that what would be 9. These questions here are not in your book, but this is just a review of what we've done so far. So we've been able to use diagrams to represent expressions. This diagram represents x plus 2 times x plus 3. Now, what does the diagram actually represent? Well, it's showing the area of the whole square if one side has a length of x plus 2 and one side has a length of x plus 3. So your quick review down here in this example, in the blanks, this would be x squared. The next one would be negative 6x because you're taking x times negative 6. The next one would be negative 2x, and then the last one would be a positive 12. Remember that we are multiplying, so it needs to be negative 2 times negative 6 gets you a positive 12. Then we could combine like terms when we write our final answer, and we would have x squared minus 8x plus 12. In your book, we are going to do just 3 of these in the next part, and we're going to use a diagram to show that each pair of expressions is equivalent. So you should be comfortable using these diagrams to show that these two things are equivalent. In the first one, we can see that x times x plus 3 does get us x squared plus 3x, because that's our final answer there. X plus 2 times x plus 4, when we multiply that out and combine like terms, we do get x squared plus 6x plus 8. And then similarly down here, x minus 5 times x minus 1, when you combine like terms, you do get x squared minus 6x plus 5. I want you to look at the factored form and the standard form, and I want you to answer this question. How is each expression in factored form related to the equivalent expression in standard form? One thing I hope you notice is that your last term in standard form, in this case 8, that's what you get when you multiply these two pieces together, your 2 and your 4. And then this 6, hopefully you notice that there's a connection here. When you add the 2 and the 4, that's what you get. Same thing down here in the next one. When you multiply that negative 5 and negative 1, you get your positive 5. And when you add negative 5 and negative 1, that's your middle term, the negative 6. This is a pattern that you notice that you're going to be able to use as we keep going with factoring. As we work on this next table, I want you to remember that you have 2 tools that you can use. You can use diagrams or you can use arrows. Either one is fine here. Practice using both. Get comfortable with both as we go. This first one, I might just be comfortable just using arrows. I can see that this is going to be x squared plus 7x by using the arrows. Now when I'm going backwards from standard form into factored form, maybe I want to use a diagram. I know that inside my diagram is going to be x squared plus 9x, and I need to figure out what's going to be on the outside. What multiplied gets me x squared plus 9x. I can see that x is common between them. X times what is going to be x squared, so that's going to be x, and then x times what is going to be 9x, and that's going to be 9. So in my factored form, I would write this as x times x plus 9. And always double check. If I used my arrows, would I get back to this x squared plus 9x? And I would. I want you to try these next 2 on your own. This is what you should get with both of those. With this second one, I did use a diagram to multiply out and combine my like terms. This next one is where it's a little bit different. So we have the standard form and we need to write it in factored form. Here's how you can use your diagram that you've already been using to help you out. You know in your diagram that you need to have an x squared, and it's probably going to be right there in that upper right-hand corner, left hand. And then down in the lower right-hand corner, you know you're going to have 12. Now I know the only way to get x squared is to take x times x. And then I need to figure out what can I multiply together here to get 12. Now the other clue is that these two pieces are going to add up to 13. So this is some trial and error. Let's say, for example, I try plus 3 plus 4, and I do 3x, 4x, and I see that right here, that does not add up to my 13x. So I try something else. I try x plus 12 times x plus 1, and I'm going to have 12x and 1x, and this will add up to 13x. I rewrite this just to make sure that it is the same as what I need right there. So in factored form, this is x plus 12 times x plus 1. For this first one, I set up my diagram like this. I know I need an x squared, and I know I need a 12. I know that these two pieces need to add up or combine to negative 7x. So I know I'm going to have an x and an x right there. And then if this is going to be negative, I'm going to have negatives here and here, because when I multiply, negative times a negative needs to get me a positive. And I'm going to try out negative 2 and negative 6. And I see that that does not work, because when I combine these like terms, I'm going to get negative 8x, but I need negative 7x. So next I try negative 3 and negative 4. So then when I multiply this out, I do see that I get that negative 7x as my middle term that we need. And so our factored form is x minus 3 times x minus 4. These two are equivalent. We are moving on here to lesson 7. Find this activity in lesson 7, and go ahead and try A and B. So again, I set up my diagram. Here's my x squared. I know that to get that, I'm going to take x times x. And then these two squares need to add up to get to 13x. So I'm thinking, what can I multiply to get 30? And that's going to be x plus 3 times x plus 10. And when I do that, I just look at combining those like terms, and I do end up with the correct expression. I'm setting up D here, and I know that I need to have x minus something in both of them, because I need a negative 11x here, and they need to multiply to get a positive number. So I'm going to try minus 2 minus 9. And again, if you try something and it doesn't work, just try something else. There is an element of trial and error here. This way I do get what I need, and so I end up with x minus 2 times x minus 9. We're going to skip to this part of lesson 3, where we're going to write each of these in factored form. One thing that's helpful here, if you notice, we always have 100 or negative 100 at the end. And if we just make a list of all the factors of 100, that can help us here. So 1 times 100 is 100, 2 times 50 is 100, 4 times 25 is 100, and so on and so forth. This is going to be helpful because when we're factoring, our factors are either going to add or subtract to get to that middle number in our standard form. So in this first one, I can set up my diagram with what I know. I know the x squared and the 100 have to be there. So I know that I'm going to have x times x to get 100, or to get x squared. Now we figure out, what do we multiply to get 100, that when we add them together, we get negative 25. I notice that 5 and 25 add up to 25. I need to have a negative here. So if I make both of these negative, and if I do negative 20 and negative 5, I notice that I'm going to get that negative 25x in the middle. So this is still some trial and error, but you can have some tricks here to make this go a little bit faster for you. So I've set up B with my diagram. I know that I need to get to negative 100. So one of these is going to be positive and one of these is going to be negative so that I get a negative number when I multiply. And I notice that I have 15x right here. And if I subtract 5 and 20, I can see that I get 15. So that's going to be a big hint that I'm going to do positive 20 and minus 5. And again, if it doesn't work when you try it out, just try something else because it is some trial and error. And I'm going to back up here because these are not technically your answer yet. We need to write them in factored form. So going back to A, our factored form would be x minus 20 times x minus 5. That is your answer. The diagram is just showing your work. In B, your answer is x plus 20 times x minus 5. That's the two things that are being multiplied to get back to your standard form.